You're very welcome to this career information evening. This is a talk on engineering and the exit routes from it. So my name is Ross Higgins. I am the course director of the LM116 Engineering Common Entry Program. So I'm going to MC this evening's event. I'm going to give a brief overview of what the Common Entry Program is all about. And the best part of this evening is that we're going to hear from graduates of our 4 exit programs. So we'll hear from a biomedical engineering graduate, we'll hear from a civil engineering graduate, we'll hear from a mechanical engineering graduate. And actually, in this case, we have 2 design and manufacture engineering students. They're not quite graduates yet, but they're almost there. So I'm Ross Higgins, and if you go on to study engineering common entry, you will have me for 1 year, or I will be the course director. I will be effectively managing the education experiences of 200 or so students for their first year before they branch off into those engineering disciplines. And those 4 engineering disciplines are led by John Mulvihill, who is the course director of biomedical engineering. We have John Mernan, who's the course director of civil engineering. We have Roland Grimes, who's here as well, who is the course director of mechanical engineering. And we have Con Sheehan, who's the course director of design and manufacture engineering. Before I get into what engineering is all about, I just want to highlight a few things that make UL really, really unique. And it was a former president that coined the phrase the UL edge. And he used that to describe the advantage that UL graduates have over graduates of other programs. And it's really kind of largely due to our fantastic links that we have with industry, and related to that, our fantastic co-op work experience, whereby all engineering students, and in fact, all students from across the university, they would actually go out on 8-month work placements with employers, maybe locally, maybe even internationally. We have the largest international exchange program of anywhere in Ireland, and this is an award-winning campus. It was awarded the best student campus in 2019, and it's the reason I work here. It is fantastic. I mean, the swimming pool, the track, the pavilion, the McGuire's Fields, it's just all fantastic. And the extent of options for clubs, societies is really, really good. We have a whole range of supports. There's maths learning centres, there are science learning centres, etc. But really, we're very proud of our first 7 weeks program, whereby early integration is deemed the key determinant of subsequent success. So if you mind students very well for those first 7 weeks, the drop-off rates really reduce. So we're proud of that, and it is still Ireland's most affordable city. So that's it. If you want to study biomedical engineering, mechanical engineering, civil engineering, or design and manufacturing engineering, you must put down in your CEO form LM116 Engineering Common Entry first. You'll study that Common Entry program for 1 year, and typically the default is you do a 4-year program and you graduate with a Bachelor of Engineering degree. Now, in 3 of the 4 of them, in civil, mechanical, and biomedical engineering, there is a 5th-year option. And if you complete those 5 years, you then graduate with a Masters of Engineering degree. And of course, there are also some post-grad options in design and manufacture engineering also. In the autumn semester, so the first semester or first year, you'll do a whole range of building block type modules. So we'll get you upskilled with maths and physics and chemistry and computing. And certainly then in the spring semester, it gets a lot of, there's a lot of fun. We introduce a lot of practical modules, and those are 2 elective modules that you will get to choose from. So one is Introduction to Design for Manufacture, and the other is Structural Engineering Design. So in each of them, you not only complete a full design process, but you get to build stuff, and there's real learning when you actually build stuff. I often just define engineering as the creative application of maths and science to design and build things, and the things then just kind of depend on the particular discipline. So if the thing is a building, it might be civil engineering that you might be attracted to. But just building on that phrase, it's designing and building, or else it could be designing and making or manufacturing. That building component of it, which we introduced in the first year, really gets students really engaged with the engineering design. So last year the points were 489. However, there's an asterisk beside that because not all students on those points were offered a place in the program. You need an H4 in maths and you need an 06 or a H7 in one of those 10 science-based subjects. And there's more details on that in terms of the course requirements at that link. But you'll be able to Google that link quite easily. But as I had also an asterisk beside the maths, if you meet the minimum point requirement and you have that other requirement of the 06 or H7 in the other science subject, and if you just fail, if you just miss out on that maths requirement of a H4, there is another way in. If you pass the UL special maths exam, you will then be offered a place in our program. And that, I suppose, details of that are there. So, like, usually the results are in August, it's going to be delayed, unfortunately, again, this year. Usually we have that special maths exam on the Thursday or Friday on the week following the issue of the insert results, and it's based on the higher level maths paper. So, I mean, you could just have an off day in your leaving cert. You might be sick on a day and just underperform. So this is your second bite of the cherry. And you can make inquiries there to Siobhan Harris and Anne-Marie Hickey. I just have the web page information there. Obviously, it's associated with last year, but certainly over the summer months, that will be updated with the details for, let's say, this year's special maths exam. And then you might be asking, okay, like how do you actually get placed into those 4 programs? So every spring we ask students what their preferences are. So we ask students what their first, second, third, and fourth preferences are, and we record those, and then we allocate spaces where there are space available. So each of the 4 programs would have certain capacities. There's a strong tradition of mechanical engineering education in UL, and therefore the demand for it is high. But guess what? We actually have the largest capacity to educate mechanical engineers as well. So the capacity for that is in the order of maybe 75 or 80. And the capacity of the other programs is in the order of 40 to 45. So with those capacities, there's plenty of capacity for all students. So typically what we do, we get students' summer exam results, we rank students, and then we place the first ranked student in their first preference program, the second ranked student in their first preference program, and we go all the way down the list, and we do our best to give everyone their first preference until there may be some people at the bottom who mightn't get their first preference. In those cases, we would do our best to give them their second preference, again, where a place exists. It's in the order of 95 or 96% of students that progress to second year that get their first preference. So the vast majority of students get their first preference, and it's only if you don't engage in the modules that you may not get your first preference. And of course, we confirmed that in the summer. And just finally, and this is my last slide, I mean, we are here and we're open to answer any questions that you might have on the kind of common entry program or any of the subsequent programs, civil, mechanical, biomedical engineering, and design and manufacturing engineering. So we're here. If you have any questions, certainly until the 1st of July, because you may have kind of some questions until then. So without further ado, I'm going to just call up Rory Quinlan. Rory is with Stryker. He is a mechanical engineering graduate, and Rory is now going to just talk about his experience on the UL program and his work experience to date with Stryker. So Rory will present. If there's some questions from the audience after Rory's presentation, we'll take them then, because there does, we need 30 seconds to kind of just upload the slides for each presenter. And maybe at the very, very end, we can answer some questions in plenary. I'll be around for another bit, and I'll be happy to answer any questions. Likewise, we have Ronan and Con.
No, that's yours. Thanks. Thanks very much for the introduction. My name is Rory. I'm an engineer, and I'm here to kind of give you my background or my kind of story about kind of why I picked UL, why I did mechanical, and kind of some of the successes I've had since I graduated. Typical engineer, I don't like talking about myself, so you can laugh at me if I make a mistake. It's fine. So what will I talk to you about? I'll give you a background about myself and why I chose mechanical engineering, but also why I chose to do it in UL. I'll talk about my time in UL and the opportunities that are here that I made the most of, and that you could make the most of too. And I'll also talk about kind of my career path, I guess, since graduation, has it paid dividends, I guess. So my background, and specifically why I chose mechanical engineering, I'd have had a strong aptitude for problem solving. So where most people might come across a problem and maybe get bogged down or stressed out, I kind of take a problem and I kind of get a lot of enjoyment out of it. So that was kind of one key reason that I picked mechanical engineering. I've CAD written there because I suppose one of the other reasons I would have maybe a three-dimensional kind of way of thinking. I can visualize something maybe a little bit easier than a lot of people, and that kind of suits, I suppose, people that are pursuing an engineering career. And I did always have kind of a strong aptitude for mathematics and physics in, I suppose, secondary school. And it is, I suppose, key to pursuing a course in engineering. So just why I chose UL, I attended many years ago now, I attended the UL Open Day here, and I kind of was taken back by the campus. It's not in the middle of a city, it's not broken apart where you have to maybe get in a bus and go to the other side of the city for a lecture. I was really kind of excited by its kind of a vibrant community. There was kind of the hustle and bustle of people coming and going between lectures. There was lecturers, it was kind of a vibrant community that I kind of really enjoyed, and I thought the facilities were really, really great. And I really, really did enjoy kind of my 4 years kind of living on this campus. So my time in UL, as Ross said, I studied mechanical engineering. I completed a bachelor. I didn't do the master's route, and I graduated in 2020. Some of the topics, and I suppose just to give it's an overview of the topics, or as much as you can in 8 minutes. I covered mechanics of solids, so where maybe you have an object, you apply a force or a pressure, how does that object react given its material properties? What kind of stresses and strains? Will it break? What's your factor of safety? Things like that. Study fluid mechanics and thermodynamics. They're kind of, I suppose, principal, I suppose, topics within mechanical engineering. So how does fluid move over a body? what are the interactions, how do you set up kind of a pump system, things like that. And thermodynamics, then the study of kind of heat and how it moves, the study of energy, stuff like that. And then we did study, I suppose, some other examples like vibration analysis, some project management, which has been key in industry after I left. And there was introduction to programming as well, as an overview. During my study here, I completed a co-op placement. So that's an 8-month industry placement. I got this placement. I filled a project management role with Stryker, which are here in Limerick. They're a biomedical manufacturing company. I suppose some of the benefits doing that here, it's real world experience throughout your course. It did build up a lot of industry contacts for after graduation. And one of the opportunities, and I was quite fortunate, I won the President's Distinguished Performance Award for my co-op placement. So this was one person in the Faculty of Science and Engineering wins this award for co-op, and it's just an opportunity that I suppose every student that attends UL can win, and it's something that you could win if you put in kind of the hard work as well in this type of course. Some other opportunities then in the course, I would say I made kind of lifelong friends in my course of study. They're all really happy now. They're all working. They all got jobs after graduation. We did a lot of, I suppose, study sessions, group assignments. We would have set up kind of group chats, and a big part of kind of making it through maybe study sessions and group assignments are maybe sending each other some memes. So I just put up one simple meme. Yeah, that was the cleanest one I could find. So just to touch on maybe some of the other opportunities and maybe accolades that I won here. This isn't a slide about me, it's not on great, it's more, this is a slide to say these are all the opportunities that are available if you come and complete this course. So your hard work, I guess, does pay dividends in this course. I was the captain for the UL Inter-College Engineering Challenge in 2017. It looks quite good on the CV. I won a research scholarship with the Faculty of Science and Engineering as well. So for 3 months between 3rd and 4th year, I studied the transfer of heat through kind of copper pipes into a kind of a condenser. And for my final year project, I did what's called computational fluid dynamic modeling of heat transfer through kind of carbon dioxide. That was the simpler title. The real title is a bit more complicated. So my career then following graduation, so I graduated in 2020 with a first class honours. In 2020, the same year, I was hired as a senior manufacturing engineer. And just last year I was promoted to a staff engineer. This is my last slide, but I do want to say, I suppose, I started college as a mature student. I was 22 when I went back to college. Quite a big investment financially, and I know there's probably a lot of parents in the room thinking, how much is this going to cost? Is it worth it? For me, the investment was absolutely worth it. I invested in the right place, UL, and I invested in the right course, and it has paid dividends. So I definitely would strongly consider doing, I suppose, mechanical engineering in UL. Well done. And thanks very much.
Before Roy sits down, does anyone have any questions? I mean, that was really, really good. Very.
Were there many girls in your class?
There was I think 75 in the class, and there was probably 10 girls, I think. Yeah.
So it's increasing every year, is it?
Yeah, it is increasing every year, but
Try to get the word out so you guys know, push that.
yeah, exactly. Yeah. There was a strong, I think, women in science and engineering group at the time as well. So I think there's a lot of sports there.
And most sports are
there are
scholarships as well. And Arab, who Amy works for, is a fantastic supporter, certainly of the civil engineering program, where they offer like really fantastic scholarships, and there's a women in engineering scholarship. Did you win that in? Or you won something else? You won
Yes.
one of the other ones.
Tell us when she's
She won in a second. Are you ready for the next?
Who's next?
Okay, Amy next? Okay, Amy, so without further ado, it's Amy Baker from Arab.
Okay, perfect. Hi, my name's Amy. I guess. How do I click? Just here. Oh yeah, perfect. I did the civil engineering program here, and I graduated just last year in 2022. And since graduating, I work for Arup in the Limerick office as a structural design engineer. So I guess first, since this was a general one, I thought I'd go into, why choose civil engineering and what actually is it. So it's everything kind of relating to the built environment and infrastructure design. So you can be kind of on the design phases, the construction or the planning, and kind of any type of project relating to buildings, bridges, roads, water, transportation, lots of different variety. So yeah, just solving real world problems and being able to take a design and being able to actually make it happen using your engineering skills. So I guess a lot of you are in secondary school and you're trying to decide, okay, gosh, what career do I want to go into and what college and what course? So I guess I just thought I'd cover why I chose civil engineering. So when in secondary school, I was interested in maths, physics, TG, art, engineering, all those things. And I guess I had a little bit of exposure to construction. My family was always doing little construction projects and you'd get roped in or doing this and that. And I did a bit of volunteering on construction things and that sort of stuff. But for a long time, I was interested in architecture. But when it came time to deciding on a college course, I kind of realized that, well, actually, maybe I'm less so interested in kind of the visual and the aesthetic and kind of the that side of things of architecture, and more so actually trying to take that kind of architectural creative vision and turn that into something that's possible through kind of the more problem-solving, practical approach of engineering. So that's what I ended up choosing in the end. So, in civil engineering, we look at kind of more specifically structural, because that's what I like now. We look at the structural skeleton of a building, and we design that, the columns, beams, floor slab, foundations, all of those things, using different materials, concrete, steel, and apply all of our loading and forces onto it and make sure that it will obviously stay standing up and it can resist wind and seismic activity, people, everything. So that's kind of, I guess, why I chose civil. So in terms of why do civil engineering at UL, the UL civil engineering program is really amazing in that it's very much project-based, very much hands-on. Ross showed you one of the earlier projects, which would be the bridge project that you do in, I think, in first year or second year?
Second year, actually.
Yes, but so that was really amazing. You get to design your bridge, build it, and make someone cross over it on a pond. So yeah. And then another big one is the integrated design project, where you get the plans for a real building that's going to be built, and you get to design it yourselves in a project group. You get to do the transportation traffic plan, you get to do the geotechnical ground investigation, the site surveying, everything. So it's really nice to actually be able to learn as you're actually doing real world problem solving and doing. So then also it's been talked about before, but there's the 8-month co-op placement in third year. So I did mine with Garland Consulting Engineers in Limerick. I was doing mainly structural steel design, and the co-op program is a really great way to take what you were learning in college and then actually apply it to real world. So it really kind of enforced that learning, taking it more out of, lecture style exam into, okay, reality. So then I decided to do the 5th year masters, which was quickly discussed before. And then for my final year project, I did it on imposed loading in office buildings and its impact on embodied carbon. I guess what you'll learn in the civil engineering course, and what's great is that in my career afterwards and some of the different college placements and work experience that I've done, lots of what I did at UL was absolutely 100% fully transferable. I think Ross actually had us do a transportation project, and I was working for Punches, and I was doing a transportation plan for them, and it was almost step by step exactly what I'd done for my project in college. So you'll learn timber, steel, concrete design. You'll do a bit of foul and stormwater drainage, transportation and traffic analysis, geotechnical, like foundations and retaining walls, that sort of thing. And then in your electives, you can choose some things, and I would have gone for construction project management, and then learning more about kind of sustainable design choices and the circular economy. Then in terms of career, after I graduated in September, I started working for Arup in their Limerick office as a structural design engineer. Arup is a really cool company. It's quite large. They have kind of projects and offices over most of the world, really. And I've had a really unique opportunity to work on major global projects in the small office that we have in Limerick. So I guess in my day-to-day, I'm working in an office environment, although lots of civil engineers do work on site. I'm more towards the office. And I'm spending lots of my time doing calculations to calculate and assess different structural components, and doing different structural models as well. So the biggest project I've been on lately, I have been on lots, but the biggest one primarily at the moment is HS2. It's the new high-speed rail being built in the UK. So I'm doing a lot of work on that, and it's really shown me what kind of opportunity is there. So even me, at my table in my Limerick office, I'm working with people all over Europe and the UK on what is one of the world's largest infrastructure projects kind of ongoing at the moment. Besides that, I'm on a lot of other projects, mostly all design and analysis work, so a lot of steel and reinforced concrete design. I'm doing a bit of due diligence work and kind of drainage as well to go with that. So I hope that gives a good overview, I guess, of why you might want to consider civil engineering, and I guess what UL has to offer you if you do go for it, and then how that can then transfer into your career beyond graduation. So thank you very much. We have any questions?
Amy, what's the proportion of women in engineering?
In the course, I'm not too sure.
I mean, it's probably in the order of 15% in civil engineering, and it's probably roughly the same in mechanical engineering. It may be roughly the same in design and manufacturing engineering. However, in biomedical engineering, it's actually about 40%. It's the, they say that girls are interested in, I suppose, people and caring. So it's that integration of engineering and the medical industry that actually seems to attract a higher proportion of girls. So those are the kind of the ballpark numbers. They vary every year slightly, but actually even chatting to the course director of biomedical engineering today we're talking about the same thing, and he was saying it's been hovering around 40% for the last few years in biomedical. Anything else? Bernie?
Just that there, like, I know a lot of the industry are now looking for women because of the gender equality, so there's huge opportunities for women in engineering. I'd just like to ask Amy how she finds it out in the workplace as a woman in used to be traditionally a male-dominated area.
There's definitely loads of opportunity, loads and loads of opportunity. And, you know, sometimes you expect, it's like, oh gosh, you know, I'm most days maybe one of sometimes 2 or 3 women in the office, you know, and really that hasn't prevented any barrier to what I can do or work on or how people talk to me or anything, you know, and you hear of people having bad experiences, but this far, I've had a really good experience with Arup. Arup is quite progressive from that standpoint and tries to, you know, make sure that there's always equal opportunity and everyone's heard the same, no matter, you know, where they come from or their background or anything. But yeah, I would definitely.
Do you find you get exposure to more areas because to meet a woman on a committee or a particular group? Because they often have to balance, so you get to go to more meetings and get to learn more.
I don't. Well, for EDI, like equality, diversity, inclusion, there would be a bit more of a push for women to join that. And I suppose a lot of companies now like to hire 50-50 for graduates. So if you're coming out of college and you're a woman, you're already at a bit of an advantage with the major companies that are hiring because, well, they like to hire 50-50. So it's a good opportunity now, especially if only 15% of us are women. So I definitely recommend it's definitely an advantage from that standpoint as well. So and also just if anyone wants to talk to me after and ask any questions, please feel free.
Cup of coffee out there.
Exactly.
But it seems that men or the male students are kind of walking into jobs anyway, so I can imagine how quickly you're snapped up. Okay, next person is it Kleena?
Yeah.
Kleena is a biomedical student.
PhD.
PhD.
Yeah, sorry.
Very good. Okay.
Thank you very much for the introduction. So I suppose, like my colleagues, why did I decide to do biomedical engineering and why did I decide UL? Like Rory, I came in through the mature student route. I actually qualified as a nurse before deciding to go back and do engineering. So I suppose 18 didn't have a clue what to do, and I'd always had an interest in science and maths, and then for some reason I was pushed into healthcare. So I ended up doing nursing, but after qualifying at that, I hated it. I didn't want to stick at it. And it was actually my brother was doing mechanical engineering in UL, and just what he was talking about in the campus and the facilities they had, the opportunities they had, I was like, this is something that I could do, and I'd really like to do it. So the more I looked into it, I was like, well, why not engineering? And I suppose being from Limerick as well, UL just seemed convenient, but UL was also seemed to have an edge in terms of engineering choice and facilities available. So I suppose that's why combining my healthcare background with my my like of science and maths to go on and pursue biomedical engineering. And obviously I liked UL because I'm still here doing my PhD in fresh tissue biomechanics. So in previous presentations, we saw some of the key modules that we studied. So I suppose more specific to biomedical engineering, we would have medical device design. We'd have anatomy and physiology. You're looking at biomaterials, biocompatibility, biomechanics of orthopedics. So I suppose what sets biomedical engineering apart from other types of engineering is that you're applying engineering principles to biological materials. And what I really enjoy about that is that biological materials are totally unpredictable. So when you're trying to characterize what I'd work on is like intestine tissue or veins and arteries, it doesn't behave like you'd expect like a concrete wall to behave. It's totally different. And I suppose I like the unpredictability of it. And again, applying my background in nursing, you can kind of come at it from a different point of view. So I suppose just highlighted in red here is what my final year project focused on. So I looked at a tissue engineering project. So I was looking at, again, porcine intestine tissue and looking at how this could be as a substitute for organ donation. So what I looked at doing was, first of all, you're not going to take something out of a pig and put it straight away into a human. Some of you might have actually seen in the last year, there was a porcine heart put into a human. So that actually has to go through a huge amount of processing before you can even consider doing that. So the first thing you do is you decellularize it, which means that you remove all the pig cells and all the pig native structures and tissue from it. And then you want to start looking at putting human cells on it so it'll function like a human heart should function. So the bioreactor here looked at applying physiological conditions to the porcine intestine, because your intestine is always moving. So when you're trying to get it to function like an organ, you actually want to apply some mechanical stresses and tensions to it so that it should start to behave like a human organ again. So I suppose that it's something that really appeals to me, that you're adding a bit of unpredictability when you're adding biological components into engineering principles. So for my cooperative education, I was in Abbott Vascular in Clonmel. They're a huge manufacturer of cardiovascular stents. So I was working with the medical device sterilization team, which was a really good opportunity because I got to work across multinational sites. So I was dealing a lot with our site over in LA. So it allows huge networking opportunities. It's a paid placement as well, which is great when you're a college student. And then you have massive graduate opportunities post-placement because these cooperative education placements often feed into their graduate roles. And I also got the opportunity to go back and do a summer internship with them as well as a manufacturing design process engineer. So then my graduate role when I left college in 2019, in the March before I graduated, I had a graduate role as a manufacturing engineer for the graduate program in Galway. So again, I was working as part of a manufacturing process line for cardiovascular stents. And then I suppose, how did I end up doing a PhD? My final year project, I was working with Dr. John Mulvihill, who you may have heard Ross talk about. So from doing that project with him, we then thought, I might be a good candidate for doing a PhD looking at the tissue biomechanics of diseased tissue. So we applied for an Irish Research Council scholarship as part of their enterprise partnership program. So Becton Dickinson, who are located next to UL, also sponsor my PhD. So again, you have huge involvement from industry there. So what I do is microscale mechanical testing of, initially I was looking at pig tissue, very glamorous, going out to an abattoir, getting some pig intestines, cutting up and doing some testing on it. And more recently, I've gotten access to human tumour tissue from UHL, and like as recently as yesterday, I was getting varicose veins from Nina Hospital and testing that. So you can see you have very much real world applications. And again, it's great to have opportunities like that within UL and what you can do in terms of career progression and further studies. It's something that I really like and that I'm really passionate about. So it helped me develop the career I want. And then I just suppose for my class as a whole, I think all of us had jobs on leaving, various medical device companies, some branched out, went further afield, a lot of them working in the Netherlands, Australia. So just huge opportunities. And yeah, the opportunity for travel is great as well and further study. So thank you for listening.
Thank you. Any questions for Tina before she sits down? Is the PhD funded?
Yeah, with an Irish Research Council scholarship, they pay for your fees, and you also get what they call a stipend, so kind of an allowance every month, not a salary, it's quite less than a salary, but you do have a bit of money while you're still in college and getting paid to do a PhD.
Fantastic. So is it full-time research?
Full-time research,
Okay, that's
yeah.
fantastic. And when do you expect to finish?
April 2024.
Brilliant.
Yeah.
Excellent. Any more questions?
I have a question. Do you think that you'd like to stay in academia, or do you think you would go into industry?
That's a good question. I suppose doing the PhD, I'll have the flexibility to do both. I suppose my career path has changed so much in the last number of years, so I'd never say never. At the moment, I think I would prefer to go back into industry. When you do go to academia, you tend to move away from the pure research, and you're looking to set up a lab, and a lot of that is looking for grants and things like that. Although there are other opportunities to work in research institutes and things like that, but I suppose I did the PhD to end up in a more technical role, so I would like to go out into industry and work in hopefully a research and development facility.
Thank you. So last but not least, so they're not quite graduates, but we have two of them. So we have John and Rory, and they are two final year design and manufacture engineering students.
Evening, everyone. So as Ross mentioned, we're both design and manufacture students, so we're in our final year. So myself, I'm Rory, and this is John. So firstly, how did we end up in UL? So I came through from the Leaving Cert straight away, and John did a PLC in motorbike maintenance. And for our co-ops, I did mine in modular automation in Shannon, and John did his in Boston Scientific in Cork.
Yeah, so I suppose I'll just touch briefly on what drew me to the University of Limerick. So I suppose first and foremost, engineering at the University of Limerick has an excellent reputation. I'm from Cork myself, so a lot of my friends went to UCC, and I can tell you, when they hear about my course, they're just jealous. Design manufacture course was exactly what I was looking for. It's a lot of really practical learning, and we'll even show you my final year project, which might demonstrate a lot of the things that we learn in our course. And even the fact that it's such a big sporting campus. I was the captain of the mountain biking club for 3 years. That's the opportunity I would never had if I went to a different college. And again, everyone's mentioned the facilities that are available to us. It's first class. You don't get it anywhere else in the country.
Okay, so why did design and manufacture appeal to me? So growing up, I always loved putting the theory to practice, and especially I did engineering in secondary school, the topic, and I did DCG say. And I always loved being able to do a drawing of a project and then bring that project to life. And that's exactly what design and manufacture does. As it says here, it's got a strong focus on projects and practical skills that later on I'll talk about my co-op, that you can take directly from college, from the classroom, and you can put it straight into work. So you cover a wide base of modules, anything from automation to 3D design, and then we do cover a lot of topics similar to mechanical. So mechanics of solids, fluid dynamics, we cover kind of half and half. As I mentioned, it is industry centered, so a lot of the skills you learn, you can bring it straight into employment.
Yeah, so I'll just talk briefly about some of the interesting projects. We do a lot of learning on manufacturing processes themselves, so we do cover a lot of injection molding at the moment with course director Con Sheehan. We touch on CNC machining, and we do some design for manufacture and SolidWorks. And as well, one of my favorite modules now was simulation and testing. So we did a lot of finite element analysis through SolidWorks. So where we'd create a 3D part in our CAD and then figure out how different stresses, strains, constraints affect our design.
So as I mentioned earlier, we cover a wide base of modules and topics. So DM4004, that's one of the modules we did in third year. And that is, you go about designing machines and their layout and for production. You also cover automation and controls. So we were in an automation lab in Schrodinger, just down the road. And they have a fantastic pneumatics lab. We were able to go in, get a hands-on approach, get your hands on the equipment that are running these lines in industry. And you really learn how to operate the valves, how to lay everything out. And for me, especially, that's where the learning comes, is when you can get your hands on, make mistakes. The equipment's great and they're really open to you making mistakes because that's the fastest way to learn. So we also do automation using Arduinos and SQL. We learn several languages. So do you want to talk about that?
Yeah, so we have another module now there this semester, MF4038. We touch a bit on CNC again, EDM, additive manufacturing, injection molding. I suppose where this module really shines is after college, out in industry. I landed a job this week in process development in exactly those areas, so additive manufacturing and EDM. Yeah, so you can really apply it out in industry as soon as you get out there.
Yeah, so as people have mentioned before, with this degree, you do a co-op placement. So again, 8 months, and it was paid. It's paid placement. I did mine in modular automation in Smithstown and Shannon. So modular do exactly what it says on the tin. They do automation, so they automate medical processes for various companies, Stryker, J&J, Viscon. So when I went in, I was a mechanical design engineer, and I was put on a team. There's quite a large design department in there, so it was unreal. It was like nothing I'd seen. So the learning you get when you go into placement is just incredible. I was first on a team, and I was working on a jig to hold a knee implant, so for sandblasting the top. So I was left to my own devices. They told me, they gave me the ask. They left me alone for a week, and I gave the presentation to the team. We took feedback. You go through the several iterations, and eventually you get to see this part that you've manufactured. So I went from that to machine layout for another company. I was on an R&D project working to 100 micron accuracy for contact lens bed. Again, manufacturing. You get to be exposed to the various departments. So I was in mechanical build. I was working with the electrical lads, the automation lads, and the validation departments. And these are all parts that I could go up to one of the workers, talk to them about what they were working on. And I could understand what they were talking about, because my degree had educated me on all of the different departments of this entire company. I could talk to them. The validation, the automation, the electrical, I had all the lingo and the know-how to be effectively communicate and be able to do my job better, because I knew what they needed from me.
Yeah, so I'll talk a little about my final year project. So the title is Development of an Autonomous Ground Vehicle for Sports Pitch Lining. If any of you have one of those automatic lawnmowers that mow your lawn, it's kind of like that, but line a pitch of like a gap pitch, rugby pitch, whatever. It's a lot more difficult than you think to drive something in a straight line. But I think a lot of like the key skills that it requires for my projects, like really encapsulate the course. So at the start, I would have done a lot of design in SolidWorks. Those of you who are studying maybe DCG in secondary school, we do a bit of that at the moment. And then manufacture, so a bit of 3D printing, water jet cutting. You can see maybe a few of these bits here, 3D printed over in the corner, a little pulley, 3D printed. And yeah, water jet cutting, turning, milling. Yeah, and aside from that, there's coding as well. So we have a little microcontroller on top of this, which we would have learned how to code in Arduino before. And wiring, we did an electrical module in first year. And that kind of brings everything I've learned almost into one big project. That really showcases the skills that you learn in design and manufacture.
So we talked to a few of our classmates today, and we just tried to gauge how people were going with their job applications. That's a big part of our lives at the moment. We're trying to get out there, and these are just some of the companies that people have gotten offers from, and some of the titles. So you can go do anything from manufacturing engineer down to R&D and metrology, and the sectors are virtually endless with design and manufacture. Everyone who produces a product needs manufacturing and design engineers. So you go biomedical, pharmaceutical, automation, the automotive industry, they all need them. So the job applications and opportunities are virtually endless. So that's us. If you have any questions,
Great job, lads. Fantastic. Any questions for Rory or John?
so we covered everything.
I guess so. Well, I'm very proud of that. I mean, really, the proof is in the employability of these guys. These guys, they have several months left, but they have job offers in their back pockets. I assume, Amy, you had before you finished as well.
Yes.
You had
I think most of our course did. I think it's pretty common.
a number. Rory, you came from Stryker from your co-op, didn't you?
Did, yeah.
So I assume you had an offer actually from the co-op.
By February, yeah, I had a job offer, yeah. So most mechanical engineers had kind of job offers 5 or 6 months before they graduated, yeah.
And Tina?
Yeah, I think the majority of our class had jobs before coming or before graduating. I think it was the UL careers fair that
I see.
you're looking for recruiting and graduate programs there.
That's fantastic. And there seems to be no end of it, no end in sight. There seems to be certainly no downturn in the demand for engineering graduates. So can I open the floor to any questions that any of you might have for me, for our graduate speakers, for Con or Ronan?
There is an opportunity for a one-to-one outside.
Oh, lovely.
Public comment.
Absolutely.
Don't want to
That's
ask
good,
the
thanks.
public, you can always get someone outside.
But if you have a question, there's a good chance that someone else might have the same question, so it would be efficient to ask here.
Sorry,
Oh, yeah, sure.
I know I've heard of biomedical engineering as well before, but you mentioned that I think 40% of the class was women. I'm just wondering as well about, is it difficult to actually, you know, if there's a certain amount of people in engineering and a lot of them want to do biomedical, does it depend on your grade if you get into biomedical? And also, you know, is there a good chance that you get it? I know you gave us some stats about overall people, 96% of people get what they want.
Yeah,
But
actually,
is it the same for biomedical?
the way the numbers have worked out over the last couple of years, actually about 100% of students that listed biomedical engineering as their first preference got it. It was just, to be fair to the course directors, John Mullicle and previously to him, Dave Newport. They just opened their doors a bit more to allow, actually I think now the capacity is 45 for biomedical engineering. So for the last couple of years, biomedical engineering has allowed everyone that had their first preference as it listed into the program. And it actually varies from year to year. So like the capacities are pretty standard or consistent across the programs across the years. I mean, they might go up slightly, but 1 year civil engineering might be oversubscribed, or another year mechanical engineering might be oversubscribed. So that just happens, and unfortunately, some students, if they don't really engage, they may not get their first preference. So,
Those that do.
or, no, yeah, 100%. Thanks. Any other questions? I mean, that was a really worthwhile question. Just to get elaborate on that, yeah.
Yeah, for lectures, like how much of your time is spent in lectures and how much time is spent like hands-on throughout the course?
Oh yeah, so like in a lot of our modules, there might be some element of like lectures, and there might be an element of laboratory work and tutorials. So the tutorials are where you might be in a small classroom where there might be a tutor helping you with some questions. In a lab situation, again, you'd be in a small group and you'd be doing some, testing on materials or testing on pig intestines or whatever it could be. And then in the lecture theatres, depending on the class size, you could be in a large lecture theatre with a lecturer at the top of the room. In terms of the time breakdown, like typically for a module, you could have 3 hours per week doing lectures and maybe 2 hours a week doing either labs or tutorials. And typically, you would do 5 modules per semester. So you have, like, in total for the year, you then have 10 modules. So that's the system that we operate on. Does that answer your question? Good question.
Well, just to augment on that, in fourth year, I'm thinking now, there's a lot of project or teamwork. So one of the key things we're trying to encourage as well is people working on their own and innovating their own projects. So they do a product development project for me in autumn, and they do a process engineering in the spring. But the teams are working together as well. So that's sort of self-directed. So that is where you're taking a project, you're getting advice from the lecturers, but you're doing all the heavy lift. So in fourth year then, the dynamic, a lot more of your time is probably spent on the projects themselves, working independently, and you're doing the problem solving. And you'll be presenting to the academic, but you'll also be presented to an external examiner as well. And so this idea, the project demonstrates your capability and competences, and that will get you hired as well in terms of goes in the industry. So we try to keep the dynamic that in fourth year particular, you're almost doing the role that you would be doing out in the industry. And we try to create the learning experiences then to craft it on. So you're almost you're taking responsibility for your own learning, particularly in fourth year, rather than being a recipient of learning that you'll be there.
And thanks for that. And I'm sure Rory, Tina, and Amy will tell you that they're always working as part of a team. So we encourage our students, well, we just form teams for our students, and we introduce group projects to them, and they work in a dynamic team from first year projects outwards. Any other questions? Yes.
What would the dropout rate be in first year?
I don't have the figures, but just to say, and I did mention it, we have a first 7 weeks program because, you know, there's an issue across kind of all universities, probably all over the world, that like some students, they may enter university and it's just a scary place, perhaps for some people, because the change of setting for them might be a bit daunting. But the first 7 weeks program is a fantastic program to just provide a whole range of supports for students that may be struggling. You know, they might have just anxieties from being isolated from family or friends. There are, you know, lots of supports on just like how to study effectively, you know, things like that. If you're struggling with maths, and you know, like maths is challenging. You don't have to be an absolute genius in maths, but for engineers, it absolutely helps. If you're struggling with maths, there are support centers for that. There's a science supporting center, science learning center as well, and we have an information and communications technology learning center as well to provide support like that. So I don't have the answer to the question about what is the dropout rate,
But it'd be low.
but we have supports to mitigate against that.
I think out of my class there was probably 75, and I think 2 people dropped out before making it to the end, but it wasn't because they weren't capable, it was because they didn't engage. They probably didn't show up to enough lectures and tutorials and stuff like that. So in my experience, I haven't seen any issue with intelligent people that get into the course, being able to complete the course as long as they're engaged.
Thanks.
Well, I suppose that one thing to be careful, sometimes when they call a person and drop out from one program, what they've actually done is they've transferred into another program in university, something more. So technically it's a drop out from engineering, but they might have gone something. But at the moment, there's one student now, and she's coming into the program because she identified this is what she wanted. And it is very difficult. You've got a paradox of choice when you're trying to fill in the CO. Like for our program, it has improved. At least you've got for engineering, you've got one primary program that are going in. But if you've literally got dozens of different options and you're trying to make a decision as to which one is the most suitable for you, it's a very difficult decision. And so when people transfer, that's always something to be considered as well. Is that there's sometimes a genuine, when they go into a program, they suddenly begin to realize, oh, this is not quite what I thought, and they pick another program that suits their interests in that.
And during the course of the first year common entry program, there are lots of points at which you get some engagement with, for example, lecturers from each of the 4 disciplines. So there's lots of opportunities for you to learn what each of those disciplines is all about. I didn't actually mention it all because I knew that the respective speakers would describe those to you, but maybe you want to find out a bit more. When you're in first year, you'll be able to talk to like 2nd, 3rd, 4th year students in those programs. You'll be able to talk to various lecturers. So there's lots of resources. And Colin's right, when you're 16, 17 or 18, entering you know, the CO list, anything or like list of preferences there, it's kind of hard to know, and that's the beauty of the engineering common entry program. It just keeps doors open, I suppose.
But just one point to keep in mind is it isn't just the students that are doing the learning here. Like one of the areas that I mentioned in my own troops is bringing sustainability and ecological concepts into all the rest of our program. Because Ireland is going to get to 50% of its carbon footprint by 2030. People get a move on. So people, the way they design products and processes, buildings, all the different disciplines are going to have to change dramatically if they're going to make those sorts of goals. So as I say to my students, like, everybody is learning because once you bring those ecological concepts in there, you still want to accomplish all the traditional technical goals, but then you have to do it within a carbon budget that's literally 50% of what it would have been from when I was an undergrad.
Thanks, Tom.
How many do you take in?
It's in the order of 200 or 210 per year.
It's probably, the point of maths is probably the bigger selection point, I'd say.
Again, that's I'm not really sure. But again, we have that special maths exam, so you can just have a bad day in the leaving cert. On that day, there's another bite of the cherry.
What's the accommodation situation like in the way, or is it worse or
There's
better?
loads about it. Yeah. I guess the accommodation crisis is nationwide. I'm just assuming, maybe I'm just guessing that it may not be as bad here in Limerick as it is in other parts of the country, but I still hear that it is challenging. Now, I do know that student villages, they prioritise first-year students, and they also prioritise those that might be from a certain distance away, or if you're from more than a certain distance away, you're prioritized. So if you're maybe, I don't know, maybe living more than 30 kilometers away, or so, I mean, the accommodations office will confirm that value. And if you're a first year student, you're prioritized ahead of second, third, fourth year students. And that kind of makes sense, because first year students need all the support they can get. Okay, thanks very much. That was great. And we have some tea and coffees and hopefully some biscuits outside as well. Thank you.
Thank you very much.